Okay, we're recording. So the first thing that I'll show you is some of the dangers Japan faces. And this is a video that I have to open somewhere else. Now, this video, I'm going to make bigger, is data for 15 years of where earthquakes have happened around the Earth. So it's going to have a little flashing light, and the bigger the light, the bigger the earthquake. And then it's going to have a scale on the bottom that's color-coded. So the deeper the earthquake happened in the Earth, the different color coding of the circle, and the bigger the circle, the bigger the earthquake. So it's going to be here and it's going to run a clock of months and years. So we start January, and this is how many earthquakes are happening. We have earthquakes every day, somewhere. And so you see the bigger ones happening, and you start to see a pattern of where they happen. And they're out in the ocean. These are where the cracks of the plates are on the Earth.
There's always gone through this earthquake.
Every one. And so over time, you have big ones, and they're going to happen, a lot of them right through here and along South America and Mexico. We do have some that are happening in the U.S. They're little tiny ones. We don't have major cracks, but we get little earthquakes.
Why do these things keep on getting bigger?
Because sometimes you have big earthquakes, and they happen along the cracks. So we're about to get December 2004, which is the biggest earthquake the Earth ever had in Indonesia. It was so big, it actually wobbled the Earth for a second. That's how big it was. And it created a tsunami wave that was 100 feet tall. That's how much water it moved. And it killed 230,000 people. So you're about to see this big circle pop up here when it gets to December, the day after Christmas. Bam. And then you're going to have a couple more because it had aftershocks. Every time you have an earthquake, you got little ones going after that. Coming up on March 2011, Japan is going to have one of the top 5 earthquakes they've ever had on the planet. And it created a tsunami. And we're going to talk about what it created as a disaster. But there's also a bunch over here. So this is Turkey and Greece, and last week they had a major earthquake that knocked down a bunch of buildings. They're still looking for, bodies and stuff. There's some up here in the Himalayas, but most of them are around this circle of fire, they call it, because earthquakes and volcanoes are usually related. And there's some down here in Antarctica, but there's places in the middle where there isn't a whole lot going on. They don't have too many cracks. And so here in another minute or so, we're going to come on 2011. And it's coming.
There's a big one over there.
Yeah, there's some big ones, and this is how deep they are. So the deeper they are, you may not feel them. So we're going to come up on March, and this one's going to poof. So Japan had a major one. And then at the end of this timeline, it's going to show you all the earthquakes at one time. And then it's going to fade out and show you just the big earthquakes. And then it's going to fade out and show you the biggest of the big ones. And so this is happening every day. Maybe not major ones, but something's happening every day. And so we got about another year and a half here left. Alaska has a lot. Japan, Russia, all of them have down there. There's quite a bit through here in Iraq. But this is mostly where it is all the time. And those islands wouldn't exist if it wasn't for earthquakes and volcanoes. So we got about one more year. Now in December 2015, it's going to stop because that's all the data they have. And then it's going to show you all of them at one time. That is all the earthquakes in 15 years. I don't even know what the number is because I can't count them all. You can see where there are plates. These are where most of them were at least 6.5 on a 10 scale. So this is the upper half. And then it's going to show you the biggest ones here in just a second. These were the 8. These are the top earthquakes that have happened since we've had recordings. And so most of them are here, here, and there. So Japan has a whole bunch of earthquakes. So Japan Japan has many earthquakes and tsunamis, and the biggest one happened in 2011. Now the 2004 one was in Indonesia, and we learned a lot about that because people didn't understand that earthquakes, tsunamis were connected. They just thought, oh, it's a coincidence they happen together, but an earthquake causes a tsunami. And one of the things that happened after we bombed Japan and they melted, they wanted to have enough resources so they didn't have to rely on anybody else. So they have they started changing how they get their energy. So they don't have a lot on the island because mostly it's volcanoes and mountains. And so they have to bring everything in. And if you have a natural disaster like earthquakes or tsunamis, that interferes with your transportation. Things can't come into the country like supplies. And then in the 1970s, the whole world had an oil crisis because we didn't have enough for all these cars. We had, big gas guzzlers like Camaros and Mustangs and stuff like that. And so we didn't have enough gas. We couldn't power the planes, couldn't power the boats to get supplies to places. So this picture down here is a grocery store from the 70s in Japan where they didn't have anything to supply because they couldn't get stuff in. And that's kind of like when we had, in April, you couldn't get toilet paper, you couldn't get wipes, you couldn't get spray disinfectant. We couldn't stock the shelves fast enough because our transportation and supply systems went down. So Japan has tried to make things independent. They've gone to nuclear hydropower and solar power, which means they get energy from the sun, from water, and from nuclear power. And one of the things that, remember when I told you they eat raw fish because sometimes you don't cook it? So this is going to be a dead squid. They're going to pour salt on and soy sauce, and it's going to twitch because they...
Who can face the greatest challenges with grace and strength? Kids can.
That is dead. They're going to pour this sauce on it, and it's still moving because salt makes things shrink up. And he's going to shove that whole thing in his mouth raw. He looks confused. He's going to shove that all in there. It's not cooked. It's straight from the ocean. So this is, squid. These are like fish eggs that are kind of like those Orbeez that, you have stuff smells good in your room. There's some wasabi, which is what you saw in the video yesterday where they were punching it. It's a really spicy seasoning they add to stuff.
Do they eat the eyeballs?
Yep.
Oh, that's nasty. It's disgusting.
The brain,
Okay,
the lungs.
I wanted to try squid, but now I don't.
And there's little suckers on there, so I don't know if it's going to stick on the way down or not. I've never eaten it, and I'm not going to. And then this clear kind of see-through stuff is probably miso, which is like a chemical jelly, Play-Doh type material that tastes however you are seasoning it, but it's like to me it tastes like snot. And it's got that consistency of snot. And then they got all these vegetables and stuff and some, nuts, but they eat what they have there because if they can't import it, they can't get it out. And so after the war, they tried real hard to have their own independent energy sources. Alternative sources. So that means hydropower, which is water, solar power from the sun, and nuclear. about nuclear that's a problem is, which is your picture today, Fukushima Disaster, is they built a power plant, kind of like Homer Simpson's job, near the ocean where there's a lot of earthquakes and tsunamis, and it went bad. So Japan is on the unfortunate 3 cracks here. So there's going to be some earthquakes. So what happened in Fukushima is that major earthquake that they had in 2011, which was the biggest one Japan had ever seen, lasted 3 minutes. So if I shake your desk for a couple seconds, I'm going to knock everything off your table. But if I shake it for 3 minutes, things are going to get really broken. So the seafloor, because the earthquake happened underneath the ocean, it pushed up the ground 30 to 64 feet because it wasn't unique. It wasn't uniform. It was kind of bent. 30 to 60 feet is 3 to 6 stories high. That is a lot of land to move all one time, and all that water had to go up and out into these massive waves. So we know at least 19,000 people were killed. We didn't find all the bodies. There were probably more that we don't even know about, because when all that water came rushing onto the shore, it's going to go out eventually. And so it took all the debris and the trash and bodies and cars, and it took that stuff back out into the ocean. And for the next couple years, their trash floated on to U.S. shores, like in California and Washington. Anything that wouldn't disintegrate, like basketballs and shoes and coolers and houses and boats and anything that, you know, that was just trash, came back. So this video that I'm going to show you, they had a lot of aerial footage and cameras in 2011 because we had smartphones. So there was way more documentation this time than there was in 2004, because they weren't prepared for that and they didn't understand they were related. So this shot right here is the ocean running away from the land. If your ocean disappears, you better run the other direction, because something bad's coming. So when all that water gets sucked out to the ocean, it's coming back in this giant wave that's going to hit that land. But Japan had practiced before, so they built stairs and things for people to get up high. They send out phone alerts real fast. The alarm goes off. Everybody goes running. Kind of like a tornado drill here.
All across northern Japan, they felt it. A violent magnitude 9.0 earthquake on March 11, 2011. It was centered about 80 miles offshore, and tsunami warnings went up immediately. In coastal cities, people knew what to do next: run to higher ground. It's from these vantage points on hills and in tall buildings that incredible footage was captured. In Kesanuma, people retreated to a high-rise rooftop and could only watch in horror as tsunami waves inundated their city, knocking buildings into rubble and mixing into a kind of tsunami soup filled with vehicles, building parts, and contents. Seawater cascaded over sea walls and into cities. This video shows the water rushing over an 18-foot seawall into Kamaishi City. The seawall here was the world's deepest and largest, but not enough for the magnitude of the March 11 disaster. It was the largest quake ever known in Japan, and one of the 5 largest recorded in the world. More than 28,000 people are confirmed dead or missing. When 2 tectonic plates push together under the sea, the resulting earthquake sends an enormous burst of energy up through the ocean, displacing enormous quantities of water. With the upward motion, a series of waves expands in all directions. In deep water, these waves travel fast, up to 500 miles an hour, but only reach a height of a few feet. A passing ship might not even notice. But as the waves enter shallow waters, friction with the ocean floor lowers the wave's speed, but raises their height. This video is from a Japan Coast Guard ship confronting a tsunami wave in shallow water on March 11. And a rare view from the air, video of a tsunami wave approaching the shoreline. In Japan, some tsunami waves reach as far as 3 miles inland. Japan may be the most seismologically studied country in the world, and with more than 1,200 high-precision GPS stations, a geophysicist at the University of Alaska used the data to create a visualization of the March 11 quake. The waves of displacement that you see were moving as fast as 5 miles per second. In this photo, the ripples of tsunami waves are seen moving upstream in the Naka River at Hitachi-Naka City. New technology left an enormous amount of visual evidence for study in years to come, and can perhaps help us better understand the power of earthquakes and tsunamis and prevent loss of life in the future.
So their tsunami was the biggest one they've ever had, and the aftershocks, there was lots of rattling. So when they built these power plants for nuclear facilities, like Homer Simpson's job is in a power plant, a lot of the stuff is underground. So if the ground is shaking and cracking, you're going to break some of the pipes and all the stuff underneath it. So what happened in Fukushima, so your picture's here. So you have these towers like Homer Simpson. And nuclear power means you take atoms and you split them apart, and when they explode, they create lots of heat and energy, and then they shoot out, they hit other atoms, and then they create this, this explosion. So to keep it under control and cool it down, you got to have cold water. So you got to have this stuff down in the ground and keep it cold water. But if you crack stuff, all that stuff is going to leak and contaminate stuff around it. Then you have all these waves that came over and crashed it out, and then you spread this cancer-causing contamination all over the place. So they had to leave Fukushima. Everybody ran for their lives. Now you can't go back because it might cause cancer, and it's going to last a few decades until it, kind of simmers down. And so what your notes, your last note, is the Fukushima disaster was caused by an earthquake and a tsunami. Because the facility got destroyed, and so now they're down a power source, at least at that one spot. They do have other nuclear power, but a big one was taken out. So what your assignment is pretty simple. You're going to open my slides. You're going to pick one of these power sources. You're going to watch the video from the link, and then you're going to draw out how does it work? How does it create energy in the first place? So you're explaining to someone who's never heard of it before. So you're going to watch the video, draw something, then take a selfie and attach it to the Google Classroom.
We're supposed to draw.
You're going to draw out how it works. So I just explained it here, but you're going to draw it out with some arrows and words. And so you either pick the hydropower, the solar power, or the nuclear power. You're going to watch the video on one, draw one. And if you get to watching the video and it's too hard, you can choose another one.
So you just draw it?
Mm-hmm. Yep, and then attach it in the classroom.